All righty, let's do this. Got to get my packet. Also, don't want to be a bad host. Want to just introduce our French, correct, exchange students. Welcome, gentlemen. All right, welcome. Don't want to be rude. Is that right, Emma? Introduction. All right, we've got. I should probably do names too, because I don't like to know. I don't like to go, hey, you, or Raphael. How you doing? Good to see you. Oh yeah, good man. We do that in France too. I'm good. And Nesco, what's up, brother? Good to see you. All right, welcome. All right, let me know if another teacher does that today. Okay, central angle. New vocab right off the bat. Central angle. Every circle's got a center, right? Every circle has a center. A central angle is an angle in the circle where the center is the vertex. Let me say that again. It's an angle inside the circle where the center is the vertex. I only have one central angle on your diagram up there. Somebody name the central angle up there. It's the angle in a circle where the center is the vertex. Where is my central angle in this circle? Thomas, start us off. Angle AOB is central. Okay, so for example, let's put a little example there. Angle AOB. That's the only one. The vertex has to be the center. Arc, you've heard of that before, but you probably never have written it in mathematical notation. Arc, piece of the circle. It's a piece of the circle on the outside. All right, so if I wanted to talk about this portion right there, how would I write that? Well, first, let's talk about the symbol for arc. Looks like a little umbrella there. And you put the letters underneath. So in this case, CA. Well, wait a second. How do you know you're going that way? How do I know you're not talking about this CA? Great question. If I wanted that arc, I would name all the letters in there. All right? So if I wanted this arc right here, I would not name it CA. I would name it CBA. So you know exactly what direction I'm going in. All right? Are there any other arcs up there? Arc AB, yeah. And do you know what they all add up to? If I added all the arcs in a circle. 360. Okay, I just want to get that out of the way. I don't know if people knew that or not. Okay. First theorem of the unit. First theorem. And it involves these two. All right. How do you find the measure of a central angle? Ready? The measure of a central angle is equal to the measure of its arc. What was the only central angle in the diagram again? Okay, so if you want to find the measure, take a look. I'm going to put a little M there for measure. If you want to find the measure of angle AOB, that's the same as the measure of what arc does AOB form? What arc does angle AOB form? AB. So the measure of the central angle is the same as the measure of the arc. So don't write this in, but if the central angle is 72 degrees, guess what's the measure of arc AB? 72 degrees. Okay? I'm not talking about the actual length of AB. I'm talking about the degree measure out of 360 it represents. So if the angle's 72, so is the arc. Pretty easy, right? So good so far. All right, different types of arcs. You probably have heard at least the first one. Semicircle. Semicircle. That's half the arc. In number one right here, I'm going to ask somebody, name a semicircle for me. Name an arc that represents a semicircle. In that first diagram right here. Name an arc that represents a semicircle. All right, let's turn it over to number 20. TR. Love the way she named it because she's going to go TRS. I'm going to follow the letters. TRS, that's this arc, which is half a circle. Got it. Semicircle here is equal to TRS. Yep. A major arc, something that's bigger. Well, actually, hold on. Let's back up. How many degrees in a semicircle? 100 and? Half a circle. You've already told me a circle's 360. 180 degrees. Yep. Okay, a major arc is something bigger than that. Bigger than a semicircle. I'm going to ask somebody right here, name a major arc. Name a major arc on this second diagram. Calm it down, boss. Trying to show us up here? And by the way, the French kid got it. So, and he's been here 2 minutes here. So I think hopefully somebody can get it here. 24? RTS. Way to save us there. Yeah. Good job, though. RTS. Nice job. And then we have a minor arc. Smaller than a semicircle. All right, smaller than a semicircle. So for this one here, minor arc, you could have a lot of choices. Not a lot, but more than one choice. More than one choice. Give me a minor arc here. 12. Garbage. There's always one in that group. 23. RS, fine. Anybody have a different one? Anybody have a different minor arc? Christian. RT, fine. How about TS? I don't know, that's risky. All right, I'm assuming that that's going to be a diameter. I don't know for sure, but TS might be a little risky, but definitely RT. Semi, major, minor, all good? All right, let's keep grinding. May need your calculator here for the next couple here. Have a calc in front of you somewhere. All right, you guys hear the word adjacent this year. I'm assuming you think next to, next to, next to. Same thing, I could have two adjacent arcs. Two arcs that are next to each other. The only condition, they have to share a point. Okay, so if you take a look at my circle O I've provided you, I'm going to ask somebody right now, name two adjacent arcs for me. All right, name two adjacent arcs. They have to share a common endpoint. So hopefully your letter repeats in both arcs. Let's roll here. Two, let's roll. Arc. Arc CA and AB, like it. Was there other ones we could have used? We could have used BC and CA. Okay, there's other arcs we could have used that are adjacent. All right, now comes the fun here. Applying this theorem we went over. A central angle is equal to its arc measure. Before we start, do you guys see a bunch of central angles in this diagram? DCB, BCA. What makes a central angle again? I'm going to grill you guys this unit. 7. What makes a central angle again? I'm going to put you central angle. You remember? It's okay if you don't. I'm not going to roast you that bad. Remember what makes a central angle? You remember? It's okay. It's all right. You're not from around here. It's all right. 17. What makes a central angle? No excuse for you. Where's the center of this circle? So any angle that's got a vertex of C is a central angle. What's the measure of arc AE? AE. Remember, how do I find the measure? I look at its central angle. They're always equal to each other. Always equal. 21, what do you got for me? AE? 90 degrees. Again, why 90? Because its central angle was 90. Let's go. Let's roll. 14, you're up. ED. 50. That's 130. The one next to it's 50, which means its arc is 50. Whoa, DBA. Follow the letters. D to B to A. Follow the letters. 25. DBA, 220. What'd you add up? 130 and 90. 220. Good stuff so far. AED, follow the letters. A to E to D, follow the letters. 22. $1.40, good. You all right there, Madeline? Okay. A to E to D, or ABD, excuse me. ABD. 9, ABD. 220, yep. DBA, ABD, they're the same arcs, right? Same arcs. And finally, BD. I ended up with the tough one here. BD. 7, redemption. BD. Man, there we go. Learning something. Questions? Try that. There we go. Oh, I love these days in elementary school, the old pie chart. Female participation in sports. What is the measure of arc BC? Whoo! Not as easy now because I just threw a percent in there. I didn't throw an angle measure. Your job is to find the angle measure given the percent, though. I know that 18%. What do we have? Okay. So you have arc AB here. Oh, that's why, because we checked, because it was the same percent. So that's why. All right, so one job, arc AB. 20% represents arc AB. How are you going to find the central angle? Or do it this way. 20% of what? 360. That'll give me the distance from A to B here. So 20%, how do I find 20% of 360? Oh boy. It's 360 times 0.2. And what's that degree measure? What do we end up with? 22? 72 degrees, yep. And CD. That's why I didn't do BC, we changed it. Volleyball, 18%. So again, yes, 360 times 18% of that. 14. 64.8 degrees. Nice. Okay, any issues? One other concept here today. Yep, we're throwing a lot at you. Okay, if I were my packet. Sure. What do we, anybody see? Master packet. On the desk. That's not mine, though. Over there. There it is. All right. Here's what you guys know so far. You know how to find the arc measure in degrees. You know how to find arc AB in degrees because you're just going to look at angle AOB and they're the same. But now here's what I want to do. Now I actually want to cut out AB, straighten it, measure it. How long is it? How long is it in inches, centimeters, etc.? How long is it? Not how many degrees. I actually want to find the length of it. So everyone see the difference of what we did a couple problems ago versus what I'm asking now. All right. You can tell how many degrees it is at a 360 by looking at the central angle. But now I actually want to cut it, straighten it, measure it. How long is it? And we got a formula for that. Ready? Not given on the formula sheet. So along with circumference, here's another one we got to remember. It's going to be arc measure which is what we've been finding all day today. Arc measure divided by 360. So again, arc measure, that should be in degrees, times a formula we've already talked about. Because I'm looking for what part of AB is the entire circle. What's the entire circle length again? Circumference. Somebody get out the formula we're using for circumference. 10, what's the formula we've been using? Pi d. Okay? So it's the arc measure out of 360 times the circumference. All right? Here we go. So I want to make sure we get through all these. Find the length. Hey, length. It doesn't say measure, so length, I need it in inches, not degrees. The length of each arc, leave your answer in terms of pi. Grilling you guys once again. Thursday, what do I mean by leave your answer in terms of pi? What should be showing up in your answer? Pi. Do not hit the button on the calculator. Pi should be showing up in your answer. All right, so length of AB. How long in inches is AB? Well, if I go to the formula, first thing I need is what's the measure of AB? In degrees, what's the measure of AB? And that's what we've been doing all today. 23, measure of AB. 90. How'd she get 90? She looked at the central angle. They're always equal. 90 over 360 times pi, diameter length. 6, diameter length. 24. Everybody, hey, take a look. You're going to leave pi in your answer. So the only thing you should be doing on your calculator, 90 over 360 times 24. If you got a fraction template, darn it, use it. Okay? Don't hit the pi button. That's going to go in the answer. 90 over 360 times 24. Leave your answer as a fraction if you need to. And what are we coming out with here? 8. Guys, 6 pi. Human calculator. Great job. You're missing something. You're missing something. I'm not going to help you here. Inches. Yes. Yeah. What do you guys measure stuff with in France? Centimeters? So you know how tall you are in centimeters, not feet? Okay, I don't need it. I'm talking to two people. So if I say, how tall are you? What, how many meters tall are you? 1.8 meters? What about you? 94? Oh, a little taller, huh? Okay, trying to show off. Okay, meters. All right, good talk. That's nice. All right. All right, next one. Little change up. Look at the arc I'm looking for. How long is C to D to E? Follow the letters. C to D to E. When you set up your formula, 40 should not be in there, but you should use 40 to get the measure of the arc. Look, I'm looking for C to D to E. That one right there. What is the, first of all, in degrees, what's the measure? All right, you're up. 1. 320. Everyone stop. We all right? Where 320 is coming from? Not 40. That's not the arc I was looking for. Over 360 times pi. What's your diameter here? 7. Diameter? Oh, boy. That's radius. Diameter is the full one, so another one. 18. Nice. Putting you guys to shame. Leave pi in your answer. $17 when you're ready. 16 pi. Thank you for the units. Let's get in that habit. 16 pi centimeters. And number 3, FGH, right? That's what you guys have on your paper, FGH. Yep. So again, follow the letters, F to G to H. How long is F to G to H? First thing, 2, got the measure of FGH. What is it? 135 times pi times, how about the diameter here? 23 diameter length. Somebody answer that? Somebody just said not here and answer. Do we have a 23 or no? What's the diameter? 6. Leave pi in your answer. Shouldn't be too many decimals, right? Or numbers after 5. 2.25 pi meters. I've also see on some papers right now, you can leave that as a fraction if you want. What's that, 9/4? So you can leave it as 9/4 pi. Just make sure, hey, if you do it that way, please make sure pi's not near the 4. It doesn't belong in the denominator. It's either 9 pi over 4 or 9/4 pi. The pi doesn't belong in the denominator. All right, how do we feel there? I got one last thing I'm going to try to challenge you with. We good on finding the length? Or are we good on length versus measure of the arc? Measures in degrees, length is inches, meters, centimeters. All right, last one. I'm going to try to trick you here. Not trick you, but challenge you. What are we looking for? Right off the bat, find the circumference formula I'm going to need then. 4, circumference. Look it up. I'm not doing this for you. Circumference formula. Used it all Thursday. 2 pi. Okay, there's one version, 2 pi r. You can also use pi d. It's up to you. Bottom line is, if you want to answer this problem for me, you got to find the radius length of the diameter here. All right, everyone good? That's what we need to find first. All right, so how can we find it based on what we're given? Arc JK. The arc length, 6.09 inches. The length. And I know this central angle is 50. All right, let's backtrack. Do you guys know a formula for length of an arc? Length of an arc. We just did 3 examples on it. We know the formula, right? Here you go, ready? 6.09, the length of the arc. Help me finish it now. Ready? 22. Measure of the arc. 50 over 360. Everyone all right? Why I'm setting it equal to 6.09, that's the length of the arc, times pi d. So what am I asking you to solve here for? Diameter. And then I can plug it into the circumference formula. All right, I'll do this one step at a time here. What's your next move to get d by itself? How can I get d by itself here? I won't call on anybody here randomly, but how do I move? Well, first of all, how do I move 50 over 360? I can either divide both sides by 50 over 360, or I heard it already, I can multiply by 360 over 50. Yep. So multiply both sides by 360 over 50. You probably remember from our Unit 8 days, I'm going to tell you not to do what yet? Round. Don't round a darn thing. So I have pi d equals, who knows what that comes out to be, a long decimal, right? So I got 360 divided by 50 times 6.09. Oh, that's not bad. 43.848. All right, I am going to turn it over to somebody for this last step here. 18, what do you want me to do now to get d alone? Divide by pi. So divide by pi. That is a longer decimal there. So here's your diameter, 13.95725,189. And now plug that into your circumference formula. All right, plug it into your circumference formula. So circumference equals pi times that diameter. Guys, find anything out there? Find anything out there? What's pi? Hey, take a look. Hey, before we divide, what's pi d the same as? Pi d is your circumference, right? So I already knew what it was equal to. So just, okay. Everyone see that up there? Made an extra move. What, Matt? Oh, I'm sure you did. Yep. What are we asking to round to here? 43.8. What are the units? Inches. Yep. So if you notice that, hey, you already solved for the circumference. It's right here. Pi d, 43.848. Nope, I need the books back. No other class.